Pardon? Yes. Yes.
Yep.
Oh, wow, this is going to be recorded, huh?
Yep.
I have two choices. I either got it or I leave. Which one should I pick? Yeah. All right. You guys know how I feel about being recorded, but that's just fine. Okay. Let me do the first screen share and see how this goes. At this point, you should be seeing a title slide. If somebody can confirm, please.
Yep, we've got that.
Okay, and you all know how to make it larger, smaller to accommodate your own personal comfort level?
Yep, that should be fine.
Fantastic, fantastic. So just a little bit backstory here about how we got to where we are today at this moment. Sorry, let me start my presentation timer as well. Keep us on track. I got a call from Graham or an email saying, can I come talk to the BITA guys? And I said, okay, sure, no problem. So he greased the skids, got me on a schedule, and it's like, okay, great. Now what? He goes, oh, well, hey, go talk to Ian. So I talked to Ian. I said, okay, Ian, great. I'll just dust off the TBC 2021 deck and bring it with me. We'll be good to go right after Thanksgiving. And that was it. And then Ian said, whoa, Mark, hey, hang on a minute here. He said, maybe we can do something. Can you do something a little different? Well, you know, the BITA group probably knows me pretty well from my visits there to your SIGs. And, you know, I always come with something different anyway. So, you know, he didn't have to ask me twice to do something different. So then he throws in the catch about doing it at 6:30 in the morning, California time, which is what it is in my time zone. I could show you outside and the sun is just barely coming up. So I said, okay, great, that's fine. So the concept here then is like, you know, we have this thing called farm to table. Do you understand that kind of concept? You know, you cut out the middleman, you go right farm to table.
Yep.
So I told Ian, I said, we're going to call this pillow to customer talk. Okay. It's hard not getting the feedback from the jokes, but that's fine. The bottom line is, if you like this talk and it's going to be a little different, then say thank you and give accolades to Ian. If you don't like it, then give me the bumps and I'll take the knocks for it. So with that, let's move in to our agenda. I put this as a informal chat because it's really it's kind of quasi presentation. One of the things that Ian you know, kind of asked me to do was you know, kind of do a style like I do with the SA solution architects and the sales guys, and when I want to just kind of, you know, get together and chat with them. And we call these things Mark Unplugged, where anything's fair game. They just throw topics at me. We have discussions. There's a little bit of controversy sometimes. And then I also share what I'm, you know, kind of working on for the future kind of thing. I share the, you know, what's happening, you know, today at the moment, but I also share what's going on in what we're looking at and some of the things I'm having under investigation. And so, so with that, I thought we would start with the video, which was a significant project I worked on last year. If you haven't seen it, it's a very short little quip kind of thing, and I think you'll enjoy it. Then we'll talk about some evolutionary moments that we've had from Itanium on forward to where we are today. Talk about system architecture and NonStop cluster solution and storage technology. It sounds like a lot of topics. It is. If you guys want to do some, you know, chat and interrupt with questions, that's totally okay, as long as we can figure out the technology. And you know, if there are questions or something, feel free to just interrupt anytime, and that would be more than acceptable to me. If it becomes too much and I don't think we're going to kind of get through everything, then I'll put a pause on it. But otherwise, let's see if we can move forward with this. So let's go on. Let me see. Okay. So in terms of the brief history, we started out with the first bladed system back in 2008 called the MB50000C. And that was based on the C7000 blade enclosure. And at that time, we were using the Itanium microprocessor chipset. And we also had ServerNet for our system interconnect. And then about 7 years later, we introduced our first x86-based solution. And that was also on the similar hardware. So it was also on the C7000, but it was on x86 versus the Itanium microprocessors. And then we also switched from the ServerNet to the industry standard InfiniBand system interconnect. And then fast forward a few more years after that, we released a new generation just this earlier this year. I guess I can still say that. It seems weird. It seems like a year ago. Hang on a second. There's a couple chat things here. Okay, I think we're good. Okay, never mind. So yeah, so we kind of upgraded the NonStop CPUs to discrete 1U, meaning the height of the CPU, and you'll see that a moment in the video. And then we also took advantage of newer InfiniBand technology back from 2015. It had progressed a bit, and I have a lot more data on that, and you'll kind of see where we're going from there. All right, see if I can advance the slide again. You know what? I'm missing something here. Oh, okay, great. Here we are in the family of systems with what we have today, just so everyone has an idea of what we're doing. We have the NS8 and the NS4. Those are our two main, what we call converged systems. And we have the high end and the entry class. We have our virtualized systems, both the high end up there. And we also have a virtualized nonstop entry class along with the NS2. And we are still supporting and selling add-on devices for the NS7 and the NS3, but they both have now, as of a few weeks ago, reached their end of sale for new system sale kind of things. So going forward then, we have our video. This is what I was looking for. So give me a moment to change the share and make sure I can do this. Now, with this video, there is audio. I'm going to assume if I don't hear anything from you, feedback from you guys, the audio is playing. But if the audio is not playing for any reason, give me a shout and let me know, and I'll restart it. But it should go. So here we go.
Mark, I don't know if anyone else has, but we can't see the video.
I was just about to say the same thing. Yeah, we've got the audio, but not the video this time.
Oh, you're not seeing the video. Okay.
We've got your slide showing, saying play video live. I can see video now.
Okay, thank you for letting me know. Let's start this over. My apologies. And the audio is okay? Volume's okay?
Yeah, the audio's okay.
Do you have everything now?
Yep.
Okay, there we go. What do you guys think?
It's nice to have some marketing for a change, Mark.
Yes. Yeah, it was kind of a fun project that I had worked on, and you couldn't imagine the extent of the project, but nonetheless, it's okay. All right, let me get back to my slides for a moment. Okay, do you see my slides again, please?
Yep, they're showing.
And I'm on slide 6 for you.
Yep, 6.
Okay, great, great. So the first thing about this, and thank you for your patience with the technology here. Uh, Share this video. Share it with your colleagues. Share it with your friends and family, and anyone you want to kind of talk about what it is you do at work, et cetera, et cetera. Just go to youtube.com. If you forget the link, just search on HPE NS8 space in between. And this is the name of the video, HPE NonStop NS8, uncompromising availability, performance, scale for mission critical workloads. It's comes straight up. It's very, very easy. That's how I find it each time. So share early, share often. All right. Let me see if I can continue here. Okay, let's talk a little bit about the NS8. You probably have seen this before. This is leveraged directly from TBC. But the purpose of showing this slide at this point is to talk about a couple of things on it in a little more depth. When we talk about the CPU architecture, we started out back in 2015 that I showed you on the history slide with the x86, and the name of that microprocessor was called the Ivy Bridge, and that was the generation of it, and it was called the NS7X1, aka the NS3 X1 at the time. And then we moved to the NS7X2, and that brought a new microprocessor called Broadwell. And again, that's an Intel named chip, not HPE names. And then the last NS7 that we did, that we just end of sailed a couple of weeks ago, was called Skylake from the microprocessor perspective. And now here we are on the NS8 in what we call X4, and this microprocessor is called Cascade Lake, and some people abbreviate it CL for short, and that's fine. I think what you can see from this is that we're not on proprietary microprocessors anymore. We're actually following the Intel microprocessor lineage. And this is our 4th generation of x86 microprocessors. I really hadn't stopped to think about it that way, but it is. And as I said, it's called Cascade Lake. And after this, there's a number of other microprocessors on the horizon that we're looking at. And so, of course, after Cascade Lake, there's something, I don't know if it's an internal thing or not, but we call Cascade Lake Refresh. And it's like well, it's really what it sounds like. It's just taking the same Cascade Lake and putting a little extra polish on it. And then after that, there's going to be a generation called Ice Lake. And then after that, there's something talked about and being discussed called Sapphire Rapids. And that's kind of like the lineage that we're looking at kind of going forward. Those are all things that you could probably go to the intel.com website, maybe even in Wikipedia, and learn more about it. But suffice to say that this is where we are. This is the roadmap, or the road that we decided to go on in 2015 when we decided to go with the x86. We knew the spins were going to be faster because this is the way the industry is going. Compared to the MIP series and some of the older stuff and NonStop that you might recall. But this is where we are, and it seems to be serving us quite well. Hopefully it's serving you quite well as well in terms of going forward. But we're very happy to be on, I'm very happy that we're on Cascade Lake at this point. And as I said, doing a number of investigations to look at the future generations and decide which chipset we're going to go on to next. And then, in addition to the microprocessor roadmap, we also have the InfiniBand technology. So if you kind of look at this here, that's our system interconnect. So we talked about the NonStop CPUs, and you saw the picture, and you saw how the CPUs are building up the NonStop. Well, what you really, I don't know if you noticed, at the very top was this set of InfiniBand switches. The system interconnect is what we call them, the X fabric and the Y fabric. And all of that is based on InfiniBand technology that helps us interconnect all of these different servers and components. Let me see what I have for the next slide to kind of walk you through this. Yeah, I'm going to skip the NS4 and come back to that for a minute, and I'm going to follow the thread of the InfiniBand. So when we started back in 2015, we were on an InfiniBand called FDR. That's Foxtrot Delta Romeo. And that stands for actually today 14 data rate. So it's running at a raw bandwidth of or a signaling rate of 14 gigabits per second, and we run 4 lanes of that. So everything you see in here in the purple and the, I guess it's orange colors, are the interconnect between the controllers and the switches and the CPUs and the switches, etc., and including the clustering solutions over here too. All of that started out running at this signaling rate of 14 gigabits per second, but we use 4 lanes. So there's, because it's fiber optic, so there's actually 4 light waves going independently. And so collectively they make up 56 gigabits per second. And if you've been around the NS7 at all since 2015, hopefully that 56 gigabits per second number will resonate with you. And compared to what we had in the ServerNet category, that was running at around 2 gigabits per second for the ServerNet 3. So I think my mantra at the time is that we increased our system bandwidth by 25x. In the story there was like, if you imagine the rush hour traffic and you having say 2 lanes in each direction, and then you wake up one morning and all of a sudden there's 25 times that, or 56 lanes now in each direction, you can imagine the amount of throughput we can be getting between the different components. So we really expanded that. And as I said, that was in 2015. And then after the FDR rate, the industry next evolution of that architecture came to EDR, extended data rate. And that had a signaling rate of 25 gigabits per second. And again, we would do this, if we were to do it, over four lines, links, lanes, whatever you want to call them. But there's 4 fiber optics going that would give us, say, overall bandwidth of 100 gigabits per second with this system interconnect. But it turns out that we rode the FDR, kind of train a little bit longer. And so what we ended up doing is we leapfrogged and we skipped EDR and we went to HDR for the NS8. And HDR, it stands for high data rate, very creative there. The engineers named this, obviously. And that has a signaling rate of 50 gigabits per second. And again, if you do the math, you're going to be one step ahead of me and realize the fact that it had a 200 gigabit per second raw bandwidth between the components. But at the same time, we came across some bottlenecks within the internal buses and some thermal challenges within the system. So we couldn't run the HDR at full HDR 200 through and through. So some of the components were running at full HDR, and then others we had to drop down to what we call HDR 100. And then, some of the astute people say, well, isn't that just EDR? Well, it is and it isn't. The EDR is 4 by 25, And when we went to HDR, what we had to do is we had to use only 2 lanes, and so this again was part of the thermal envelope that we had, and so we had, as well as the bandwidth through the PCIe buses on the servers. So we had to drop the bandwidth a bit. So we're using in some cases only 2 lanes of the HDR. So that's 2 times 50, which gives us the equivalent of the EDR rates. And we always have interesting conversations about who's talking about what when we're talking about 100 gigabits per second. The bottom line is it works, and that's all. That's the good news. So we got this to work, and most of the components are running at the HDR 100 rate. I always get the question back on the NS7 days. Now that we were going at 56 gigabits and we increased to 25x over ServerNet, could we saturate FDR in that environment in the NS7? And the answer was yeah. Eventually, we were able to, as the I/O and the SSD and the storage got more responsive and lower in latency, we were actually able to saturate the 56 gigabits. So going forward now, we're at HDR 100. People have asked the same question once again. Could we saturate the HDR InfiniBand? And I believe the answer is I'm going to say theoretically yes. I don't know that we've actually done it in practice. I haven't heard, if the engineers did that test. They did the test on the FDR probably just because they were bored or something. But the HDR 100, I don't know that we've actually saturated it in real live conditions, but theoretically we could do. And so now you say, well, I talked about the future generations of the microprocessors. Well, there's future generations of InfiniBand. The industry is not standing still on this whatsoever. So the next thing is called NDR, which is on the horizon, and that's for next data rate. And again, I didn't name these, the industry did. And that is going to run at a 100 gigabit signaling rate. And we're going to use 4 lanes of that. And so it'll be 4 times 100, or it'll be a 400 gigabit per second bandwidth or throughput amongst all these various components. Now, whether we stop at NDR or not clear. HDR is still a viable technology. NDR is not released yet, by the way, and so we don't there's nothing to work with on NDR at the moment, but it's all in the specification books, so it's out there and it's theoretical, but it's definitely something that is on the horizon that we could potentially go to. But I want to emphasize too that if we get off the HDR 100 and we get into a situation where the internal bus bandwidth increases and the thermal properties allow us to, we could even just bring everything to a full HDR running at 200 gigabit raw bandwidth environment. That would be a nice notch up as well. But at the same time, you always want your buses to be a higher bandwidth and higher capacity than your compute, so you're not the bottleneck here. So what I try to do with the InfiniBand is stay one step ahead of everything else, so that so we cannot saturate it, or that we absolutely don't saturate it in most practical situations. And that's what I try and do. And so I think getting up to a full HDR and kind of replacing the HDR 100 components and getting past that, I think that'd be a nice next step for us. And as I said, HDR is a very viable kind of thing. One of the disclaimers that I'm going to make at the end, and I'll make it now, is that a lot of this future stuff I'm talking about, it's following industry roadmaps, and you can go to various vendors, you can go to wikipedia.com and you can read up on all this stuff to your heart's content, whatever you wish, but in whatever your interest is. But suffice it to say, it works very nicely, because if you go back to my history slide, 2 of the main things that we switched to when we switched off of the the Itanium line to the x86 was the microprocessor for one, and I talked about going, through the lineage of the Intel microprocessor family and following that. But in addition, the InfiniBand is also kind of leapfrogging with that too, and it has a very aggressive roadmap and nice future ahead. So you can say, or that I could say, that I'm very happy that we stepped on those and those paths, and that we're going down those direction. Now, while we talked about the NDR at a 100 gigabit signaling rate, which is actually pretty amazing by today's standards, there's also a standard out for XDR, and that stands for X-ray data rate, or extended data rate. I'm not sure what the X stands for in this case, but they needed something, and that's actually doubling the data rate one more time. So the signaling rate is 200 gigabits per second. And if we did four lanes of that, it would be 800 gigabits per second in the system interconnect. So when you look at the amount of transactions, and where you might be growing your business and so forth, and again with the system interconnect, I just want to stay at least one step, if not two steps ahead of anything else that could possibly bottleneck for the foreseeable future. I think we have that covered, and it's actually a pretty exciting kind of thing. And there's a lot of headroom in a lot of versatility in these new architectures. And now, of course, XDR is still on the table. It's a drafting table. There's specifications being written for it. I believe they're finalizing them if they haven't already been finalized. But it is a thing. It's conceptually it's there. But at this point, we're still, reminder that we're focused on HDR, and we really like how HDR is working for us these days. Okay, and then going back to the NS4, just very briefly, it's going to follow the same thing and benefit from the same kind of architectures. So we have the x86 and the similar kind of Intel, Xeon roadmap. And then the system interconnect, if you weren't sure about it, is also following the same path as the NS8. No difference there at all. Now, in addition, one thing that we've introduced recently was the clustering solution. And what the clustering solution does is it allows us to expand out the NonStop solution. And so as you have the various nodes, and some people have said to me, well, isn't NonStop itself, each node, a cluster solution? Because again, in the video you saw multiple CPUs, which are servers of themselves, as cluster, and says, yeah, you're absolutely right. So the NonStop itself is inherently a cluster solution within a node. And then said maybe we should call this our super cluster solution, because what it does is it connects all the nodes together. And then you can have up to 24 nodes, and each node can be made up of a NonStop system, which is up to 16 CPUs. And if you multiply that out, you can actually cluster up together 384 NonStop CPUs. And I'm not sure that people actually kind of grasp that scale out factor. And it's linear, by the way. This is this is not SMP, this is MMP, and it absolutely is linear. So it's a tremendous scale out, kind of thing. And we're looking for more workloads, more transactions, to fill this kind of, capacity that we have. But also at the raw, foundation of this, and I'm going out of order, it's all connected and interconnected with the InfiniBand. And so speaking of the InfiniBand side of it, we have the NS7, which was the FTR. Remember that 14 data rate running at 56 gigabits per second. And this is kind of showing the different distances that we have between the different nodes. And then we have a long distance solution here that goes up to 65 kilometers using DWDMs, which are modems and link extenders. And then we also have multiple zones, so you can actually isolate the zones however you wish. and you just can't go over the maximum of 24 nodes within the solution. And there's nothing magical about 24. If we had to go beyond that, we absolutely could do, architecturally speaking. But most of our customers are not coming near this limitation. So again, I want to create infrastructure that gives us the most bandwidth and throughput, and just kind of stays out of the way, so it's not an issue for you folks, and we don't reach limitations. And then on the NS8 here, we have the cabling. We use EDR technology in some cases with active optical cables. So these cables themselves are devices. They have microprocessors in them, 4 of them, 2 on each ends of the cable. They're actually powered, which is what creates some of the thermal challenges for us. And they connect to the switches and to the other nodes. And at this point on the NS8, we support a single zone infrastructure. I am looking at additional things to increase that, as well as various projects to, maybe increase the distance. There's a number of things going on. Nothing we can really, confirm or deny at this point. But suffice it to say, I do have a lot of investigation and research going on in this area. If you guys, again, if you want to interrupt at any time, feel free. I said this is kind of a, interactive kind of thing if you wish. I know there's a lot of folks on the phone, but it's fine. Coming back here to, and I'm bouncing around just because it was supposed to be a more casual kind of thing. But pictorially, I thought this can be a fun kind of slide that I like to show, and it helps me speak to it. But with the NS7, each one of these horizontals represents a zone. So you see 3 zones, and then you see the different nodes. And these are, however you want to populate it. And they can be separated up to 65 kilometers. On the NS8, we have single zones, and these orange, I guess red or orange, whatever your screen looks like, those are just 4 nodes now connected there. And, if I forgot to mention, too, a couple of interesting points, we end up with a single image here of the operating system in the database. So that database then, has a lot more compute, going against it when you do connect up to the 24 nodes. So that's a huge expandability for our SQL. And then if you wanted to join the NS7 and NS8 within the same cluster, you can do. This is a very nice feature that we're bringing to the table, or that we've brought to the table. So you see the green and the red, and green and red and green and red, and you could do that, consistently going through as you wish. So we have the mixed cluster kind of thing. And if you want to do this for migration purposes, it's fantastic. If you want to, kind of run NS7 and NS8 for some time in a common environment, you absolutely can do that too. So no worries here, and definitely lots of compatibility and investment protection. Okay, so let's kind of go forward a little bit and move now into storage. So like the microprocessors and the system interconnect with InfiniBand, I thought I would talk a bit about hard drive HDD technology. So when we talk about HDDs, I probably should have brought one here as a show and tell kind of thing. Now that I can do this kind of stuff, but it has a platter. Oh yeah, do I have one around? I only have one where the parts are taken apart, so I don't have one in whole. But essentially, it's a spinning disk. It's a platter, like this, of one platter or more, however you want. And then it has heads on it, and the heads fly over the disks, picking up the signal, and like 10 angstroms distance between the head and the disk. And it's something that most of us probably grew up on, over the years. Now, what's happened with the HDD technology is that they found that as they make the disk spin faster and faster, the latency goes down and the drive goes faster, and that's great. And so they went, we had 5,400. Well, actually, we even had like 1,200, 2,400, 4,800 and 5,400, then 7,200, and then we had 10,000 RPMs spinning technology, and then we within the last 10 years that moved up to 15,000 RPM technology. Some of the NonStops about 10 years ago were still using 10,000 RPM. And when we got to the 15,000, one of the things they started finding out is that things were going to wear out on these things, the bearings and the bearings that the platters spin on. And they realized that 15,000 is probably as far as they can take that. And at the same time, the performance of SSDs, solid state technology, was coming up, and it had a much lower latency and higher higher speed performance, IOPS, if you will, IOs per second, than the HDDs. But SSDs were kind of pricey and so forth. But as the price of the SSDs went down and the capacities were going up, then the HDDs at 15K RPM kind of said, okay, why are we having these things? And then because the HDD is reaching technology limits or physics limits, so that doesn't make sense. So the 15K RPMs are the fastest hard disk drives that we're ever going to see. No one's going faster than 15K. And quite the opposite. Now, the HDD technology has gone down, and it's gone down back to 7,200. And you sit there and say, Mark, that doesn't make sense. Why would we go back to 7,200? Well, the reason they're doing that is because the density of the HDD technology is now going up. And the density of the HDD technology has gone up much faster than the SSD technology, because the SSD technology density is linear. And if you want that to go up, so if you're getting, say, a 100 gigabyte drive, you want 200, you pay twice the price. You want 400, you pay 4 times the price. And that's not a very good cost envelope to increase the density significantly. So where we are now is with the HDD tech, and I'll come back to techniques on the SSDs in a moment. But the HDD technology now has gone to the point where they instead of the RPMs, where they've brought back down to 7,200, but instead of running them in what's called an air-filled environment, they run them in a helium-filled environment. So they actually seal the HDD in the mechanism there. So the density of helium is less than that of the density of air. So it has less aerodynamic force on there, which means that the head can move quicker. The acceleration of the head can move faster, and you can actually add more platters. So in which increases your density significantly with more heads, lower aerial density, and ultimately lower power, and keeping the power envelope the same too. So suffice it to say, on NonStop we support a 300 gigabyte, 15K RPM drive, which is quite old technology, but still a very viable product today in the mission critical space. But where the technology today is in HDDs, which we actually use in the VTC, is upwards of 16 terabytes in a single device. So 16 terabytes. Did I get that right? Yeah. In a single device. And I believe we have 18 terabytes for sale nowadays as well. But if you buy a VTC, you can actually get it with 16 terabyte devices. And that's by the use of these higher density, helium-filled, lower speed, kind of devices. Now the question is, are we going to bring those to NonStop in the future? And at this point, I look around and I talk to our customers about this quite frequently, and I say, do you need 16, 32 terabytes in a single device or in a mirrored volume? And customers come back and say, no, that's not what we need. And by the way, because it's running at 7,200 RPMs, the IOPS are slower. So you don't get the benefit of the low latency like you do with the 15,000 RPMs. But suffice it to say, most of what we've been doing now is focusing on solid state drives. And I can't recall when we first brought these out. Maybe some smart person on the phone will be able to tell me whether it's been 8 years or 9 years or 10 years. I can't recall. But the SSD technology, solid state drives, so no moving parts, just NAND and microprocessors in there, is something that's really taken a stronghold now in NonStop, to the point where by default, all our system drives in our systems we ship today, most of them, with very few exceptions, are using SSDs. And then our customers are also using and focusing on SSDs as well for their data drives predominantly. We still sell the 15K RPM drives, the 300 gig, but that's definitely going down. But we're still using it. And now, what's interesting is in the SSD technology, the question is how do you get that price envelope down? And we started out with the problem with SSD technology is that they wear out. And so they do have a finite life. It's like ink or toner in your printer. You print more, you wear it out, and then you have to replace your toner. And the SSDs have a similar kind of phenomenon, and it's called the write phenomenon. So the more you write to them, the more you wear it out. Every time you write, you wear it out. And you can read from them forever. There's no limit on the reads, and reads do not wear it out. So we originally started out with write-intensive drives. And the question is, how many times can you actually write with these drives? And when we started at the beginning of the NonStop, SSDs, we were doing 20, 25 drive writes per day, which means whatever the capacity was. If you kind of look at this little example for a moment, it wasn't this, but for instance, if it was 100 gigabyte capacity, write intensive at 10 drive writes per day, it kind of gives you an idea of how long that drive would last. And that says how many times you could actually write the entire 100 gigabytes every day for 5 years before you would wear it out. So we took a very conservative approach with write intensive drives, but they're pricey, and the ones were quite expensive. And so what the industry has done is they came out with what I would call cheaper NAND, and make it a little less expensive and increase the densities as well, because you can't keep over provisioning these things at the higher capacities and still maintain a price point that's attractive. So the mixed use says, well, if you take this drive and use it like a 50-50 kind of thing, then your drive writes per day, in this case, they might come down to 2.5, and that would be like a mixed use kind of drive. So if you increase the capacity to 400 gigabytes and you reduce the drive writes per day to 2.5, that is going to equal the same capacity as your 100 gigabyte drive, which was write intensive at 10 drive writes per day. And so you kind of get the sense here that the price of making this, or the cost of making these two, is exactly the same, but one gives you at a capacity of 100 gig, one gives you a capacity of 400 gig, but the difference is the endurance. How long are these going to last? And if you really beat on this drive really hard and you're really writing it more than 2.5 times per day for 5 years, then after that, then it's going to, kind of wear down. And then you say, well, Mark, that's still pretty good, right? Well, yeah, because then if you increase that capacity and say go from 400 to 800, and perhaps you can change your drive writes per day down to 1.25, you can look at it like that and see where you're going. Beyond mixed use, there's drives called read intensive that are like 90% read, 10% write. So that this brings down their drive write per day by a factor of 10 to like 0.1 or 0.2 even. And then there's something called even very, very read intensive, which is like 0.01, kind of thing. So when you when you kind of look at your phones and some of your SD cards in here, those are using the same kind of technology, but it's very very read intensive kind of thing. So you're not writing that that much. So when you look at all these kind of things, what does this mean for NonStop? Well, it means we have choices, and we just have to think about where we want to go in the future. So we have choices to increase the capacity. We have choices to decrease the endurance. And I'll be the first to admit, when I started with the endurance, I took a very, very conservative approach. I mean, when you look at 25 drive writes or 20 drive writes per day by today's standards, that's just crazy. It's really crazy. Our current ones that we use are 400 gig capacity with 10 drive writes per day. And by today's standards, that's still kind of like, kind of crazy. If you do the math on that, that means you can write 400 gigabytes to that drive 10 times a day, every day for 5 years. And that's still, well within the mission critical space. And so I'm doing a lot of investigations to figure out, where we're going to go next. And but the good news is, again, we're on one of these trains, we're on one of these bandwidths or paths, if you will, that we're following the industry, and we have choices, and that's exciting for me, the fact that we have choices. I think what I'm going to do is where we are in time is kind of stop here and open it up for questions. There's a couple of other things that we were going to talk about. We'll talk about the XP Gen 2 that was just released. I announced that in November at the boot camp. That's very exciting, and they have backwards compatibility with the XP8 Gen 1, so you can do in place upgrades, investment protection. So if your customers want to, you want to go to the Gen 2, you can absolutely do that, no problem. You get some performance there. We increased the logical volume size, so of our volume, because as we're going forward with this, we have limitations, architectural limitations within the system, and so now we could have LUNs up to 1 terabyte, and this would have to be created with the XP storage. But again, if we wanted to go beyond 1 terabyte, we could increase again our architectural limits within the system, within DP2, within the file system, and so forth. And we're looking at various things like this, where we have these limits, and then what it takes to actually expand them. The limit prior to this was 600 gig, and that was from the NeoView project, if you remember that. But we haven't really gotten to that point yet, because we're still at 400 gig for the physical volumes. But the XP, you can create LUNs that big, and you can create 1 terabyte LUNs as well. Customers like that for logging, and very, very large log files with base 24 and other applications. So that's something we can increase and kind of go forward again. We have our virtual tape products. The thing that we did on these recently is we increased the up to Windows Server 2019, and again, that too is will follow industry standards, and we'll be looking at future Windows Server 2022, I believe, is the next one that we can potentially look at and see what's coming up in that. But again, we're following that path with the industry standard. Our console 2 is a similar thing. We're on 2019, and we're going forward. I guess I should mention too, if you hadn't noticed, I talked about the SSDs and the data drives. The CLIMs have system drives in there, just like the console does. But on the CLIMs, the drives there are SSDs. And those are actually mixed use SSDs, and have been for a while, because there's no need to have them very write intensive. So we're actually using mixed use SSD technology within the CLIMs. The consoles are still using HDDs, I believe, at this point. And yeah, that's kind of where we are. I always like to make note of our partners and give them the proper acknowledgement they do. In any talk I do with our customers, without our partners, we would be nowhere. And so just take a minute to acknowledge them on this slide. And once again, questions, comments? Do you want to thank Ian for this, or do you want to throw the stones at me? Just give us the feedback.
Done them
I
into
know you guys
silence.
are always a quiet bunch, but let's see.
Any questions for Mark?
Mark, I got a question actually about the NS7 InfiniBand. If you could
Yes.
answer possibly. Yes, we had a hot stuff recently about you need to reboot your InfiniBand every 365 days, which we've already done. Is there looking to be like a fix for that? I mean, obviously it's on the old NS7 systems rather than the newer ones. Just wondered if you knew anything more on that one.
Yeah, beyond what is mentioned in the hop stuff, I don't know if the vendor is actually going to supply us a solution for that, or we just use the workaround. So I can't speak to it. If you're curious, I certainly can go back to the vendor and go back to our engineering team and ask them where we stand on a permanent fix. So if you wouldn't mind, just shoot me an email here, right to Polllans@hpe.com, and put that out there, and I'll be able to get back to you and let you know whether it's going to be a permanent thing or there's something on the horizon they're working on.
Okay, will do. Thanks, Mark.
Yeah, be happy to get that for you. Okay, appreciate the interaction and the feedback. But Ian, shall I turn it back to you?
Thank you, Mark. Yeah, thank you very much for doing an unplugged session today. I think it's been well received.
Okay, thank you. Appreciate it. Thanks for having me.
Thanks. Have a good day. Thanks. Cheers, Mark.
Yeah.